approval. And let's immediately move into the first topic. The first topic I want to discuss, to present, is the concept of measurement. Because I believe this is something that I have been insisting for quite some time, that there is a difference between collecting data that often are expressed in terms of numbers, and assuming that these data are measures of something. And my objective for today is to demonstrate to all of you that unfortunately this is not the case. That many times when we see numbers, when we see data, when we see the material that is produced during a data collection, field operation of a survey, or when we see variables that are disseminated with the material, the measurement problem have not started to be addressed yet. So this is particularly true, especially true, or I would say specifically true, when we deal with human and social research. So if we were all engineers, mechanical engineers, architects, or other people involved into constructions or physical sciences, even doctors, like things like biological science, then you can say that in order to collect the data, you need to have in your hand a measurement instrument. So if you want to do an anthropometry measurement survey, you need to carry with you a scale, a ruler, or a band to measure the upper arm circumference. So the moment in which you collect the data, you are operating an operation of measuring, which means that the tool that you have has already embedded a measurement reference scale and a procedure that generates the readings, the numbers. So I don't know if you ever used this band to obtain the upper arm circumference, no? It's like a little thing, it's like a, yeah, I have it here, this ruler. It's particularly done that you put it around the arm and then you read the number. So the moment in which you have done this, you have your number, and your number is the measure that you want. But this is not true when we deal with social and human research. Why? Because the things that we want to measure in the social and human research field are not directly observable attributes. You cannot have the arm around which you can apply your tool. Think about it. And we are in the area of two particularly important constructs. Resilience. What is resilience? Food insecurity. What is food insecurity? These are ideas. These are concepts. There is a technical term. These are constructs, mental constructs that we would like to measure, but we will never, ever observe the severity of the food insecurity, the ability of resilience, the resilience power or resilience capacity directly. So when we speak of measurement of these things, we need to understand that there is an additional step that goes from the moment in which we have data, information, can be qualitative, quantitative, represented through numbers, represented through video, through recorded material, anything. This is our data and the measure that we want. And there is a process that only exists in the social and human research that requires that you transform the information you have into a measure. So the first lesson of this meeting today is, in human and social science, the measurement process starts after you have collected your data. The data, even if the data is recorded as numbers, is not a measure. Having said that, I have to immediately qualify and say, in reality, no, because if you don't have a good idea of how to do this process after you will have collected the data, you probably will end up spending lots of resources and wasting a lot of resources in collecting data that is less than optimal. There is also an approach of saying, okay, let me see whatever data I have, and let me try to figure out whether I can get to a measure of resilience or a measure of food insecurity. But you will end up discovering that maybe some of this data is irrelevant, is not so useful, is less than optimal. And therefore, the process of measurement has also a feedback loop in which, by learning how to do this analysis, you improve your knowledge in terms of how to collect the data, which data to collect. Okay? Now, so having said that, there are some principles of measurement theory and practice that are very common across the scientific, the physical sciences, biological science, and the human and social science. Which means that if you want to talk about something as being a measure, it is not enough that these things is expressed in numbers, because sometimes numbers are just labels. Numbers can reflect simply an order, 1, 2, 3, 4, 5, maybe first, second, third, fourth, and fifth, rather than 1, 2, 3, 4, 5. They may be labels to just identify groups. 0 and 1 are two numbers that are often used to just identify yes and no, discrete qualitative classifications. So the question is, what is it that makes something a measure? And this is a definition, or a possible definition of a measurement, by saying that in order to say that a specific measurement system produces a valid measure, it must be true that the numbers that you call your measure are, which means the reading on your instrument, must be in a one-to-one correspondence with the attribute that you are trying to measure, meaning that the numbers will differ, will change. The tool, your measurement instrument, will produce a different number if and only if the attribute changes its magnitude. And this must be a very precise relationship. Double the magnitude, the number should be twice as much. If the magnitude shrinks by 10%, the number should be lower by 10%. Otherwise, what you are producing is not a valid measure. So I'm giving you a definition of validity as defined into the metrology discipline, which is the science of how to come up with measures. Now, think about with this example in mind, no? I think many of you are familiar with the fact that even including during the MDG era, one indicator of food security was the prevalence of underweight children. But now, imagine the situation in which a child is sick, and despite eating, he won't gain weight because he has a diarrhea, because he has some other condition, which means that if we measure anthropometry, height and weight of this child, the number may change even if the food security situation of the household where the child lives is not changing. So the information that is contained in the height and weight do not depend only on the food security, which means that while you can claim that in anthropometry, children anthropometry measure, there is some information that relates to food security, child anthropometry is not a valid measure of food security. So I'm also drawing here a distinction between a measure and an indicator. And the main purpose of these meetings would be to understand the difference. So the first property of a measure is validity. The second important property of a measure, and this is true even in engineering, even in nuclear science, even in subatomic physics, whatever. The second property of a measure is reliability. And here terminology starts to be a little bit confusing sometimes because reliability can be decomposed in two elements. One is precision or accuracy, and one is correctness or lack of bias. And sometimes there is confusion because some people use the expression reliability to refer only to precision. And so you need to be a little bit open-minded in understanding exactly what are we talking about to interpret the labels. But the concept is relatively simple. So a measurement system, a measurement tool, can produce very precise measures, meaning that the difference, if you apply your measurement tool to a given object, the same object again and again and again, the measures that you obtain are very similar to each other. So variations of the measure around the mean are very small and are not systematically in one or the other direction. This is the property of precision. Accuracy, if you want, even though, again, accuracy sometimes is referred to the other property. So precision But then we also need to have correctness. If you are measuring, like many of us in these days are monitoring their temperature, no? Because we may feel that the coronavirus has hit us, or for some reason, some of us have been under surveillance, we need to take temperature every day. But I have tried with 2 different thermometers, and they systematically give me a different number. Even though each thermometer is very precise in the sense that if I take 3 measurements of my temperature now, the thermometer gives me 3 numbers that are very close. Using another thermometer, I have 3 very close numbers, but different. So there is a problem of calibration. There is a problem of accuracy in the sense of correctness. It cannot be that both thermometers are correct. One is correct, the other one is biased, or maybe both are biased. So, in order to evaluate the bias, one should have a gold standard of reference. Meaning that if I have the best thermometer ever built on Earth, I should take the temperature with that thermometer that becomes my gold standard. And then I can evaluate the accuracy or the correctness of my thermometer with reference to the measure produced on the same object by the gold standard. And this concept is, again, the combination of precision and accuracy determines the reliability. And this is a property not of one specific measure. It's a property of a measurement system, of a measurement instrument. So, to summarize, I think the 2 important properties that we need to recognize and be able to evaluate, because in the end, our assessment of the quality of the measurement figures, of the measurement data that we produce, is a combination of validity and reliability. And reliability in itself is a combination of precision and accuracy. And in this sense, if I had ever one day I will write a book on statistical analysis, the cover of my book will present a quote by a philosopher, an English philosopher that wrote a book in late 1800s. His name is Carvet Reed. And the quote is, "It is better to be vaguely right than exactly wrong." Translated into these properties of precision and accuracy, he says that sometimes it is better to be approximately right when you produce an assessment rather than pursuing a false sense of precision and producing results that are precisely wrong. Because in terms of the guidance that we need to give to policymakers, it's important to be approximately right and honest about the precision. And this is, if I have to give the list of the first of capital sins that analysts, quantitative analysts do, is never conveying the correct assessment information around the precision of the estimates or the assessment that they do. All of you have heard the announcement, the launch of the Global Food Crisis Report yesterday. The news is that Arif Hussain, the chief economist of WFP, has made an assessment that because of the COVID epidemic, the number of people in phase 3 or worse classified using the IPC classification will double. And he didn't stop there, but he said instead of 135 million will become 270 million or 69. So given even the numbers. Well, that may or may not be true. Actually, if I had to say a bet, I would say I would bet all the money I have that this is wrong, because nobody can tell what will be the number at the end of the COVID epidemic. And to present such an assessment without carefully commenting on the level of uncertainty that remains around the measure can be quite problematic, because can actually divert resources from other areas that are equally important, like health. So it's very dangerous. It's very dangerous to put numbers in the public domain that can get picked up by journalists without having also some indication of, okay, but are we talking truly of from 100 to 200 million? Or is it something in between 110 to 300, so that we really don't know which is the truth? So in this sense, what I'm saying is that good practice should always lead to attach to the figures also some indication of the residual margin of uncertainty that is unavoidable every time we make an assessment. When I see the World Poverty Clock online, when I see IPC assessment, and some of you may be culprit of having participated into some of that. I'm talking to my guys here because some of them have been part of IPC group or WAM, MWAM assessment. When you put up a report in which you present the number of people up to the unit, 1,324,655 people, that is giving the wrong impression of high precision, when in reality there is none. Presenting the number in terms of intervals is always a better way to do this. But why I say all this? First is because I am very, very passionate and sanguine about these things. I think there is a problem. There is a problem in the profession, and there is a problem particularly in the food security assessment profession. And FAO itself and myself, I have been constrained and forced to be wrong whenever the figure that we produce gets transformed into a public report, in which communication people find it difficult to properly convey uncertainty. I think most of us who work in the field of quantitative assessment do not pay sufficient attention to communicating the uncertainty. And actually, in my opinion, statistics is not a mathematical, a branch of mathematics. Statistical is not learning on how to use some models and do some computation with random variables. No. Statistics should be a branch of philosophy, should be the thing that helps human beings to talk about, to discuss about things while recognizing uncertainty. So it's how to logically, rigorously, formally deal about problems, discuss about scientific inquiry, while being aware that there is uncertainty. That, like Socrates would say, the only thing I know is that I don't know. And how much I don't know. How relevant is what I don't know as opposed to what I know. This is what statistics is for. Going back to the distinction between data and measure, going back to the problem of what happened when we have to measure things that we cannot observe directly. Statistics is the tool that helps us to filter the noise from the signal. It's like I am exposed to information, I receive this information, it's like a sound that reaches my ear, but somebody speaking is telling me something, and there is also noise in the background. And noise makes it more difficult to understand exactly what's going on. And so I need something, a filter that allows me to separate what is relevant, what is the signal, what is the information that the data is conveying from what can be considered noise, disturbance, errors, accidents, whatever. This is what statistics is about. And now I conclude by saying, because of the nature of the things that we want to measure, the role of noise, the need for using statistical tools to transform the data into measure is fundamental. Okay, now let me stop here by devoting this last 8 minutes that we have today to questions. So please raise your hands if you have a question, and I will call you upon. And Danvers, just write it in the chat box. And I saw that the number of people that have joined has grown. So I see Nicholas and a number of other people come out.
Benjamin Jishan is from Somalia, sorry.
Yes, and also Kamau is...
Kamau is still from Somalia.
But it's not the Kamau I know. That
no, it's another Kamau.
Okay.
It's so, Nicholas. He's another Kamau.
Okay. But so apologies for those who have joined later, but now we'll need to close sharp at 3 o'clock. So we have 7 minutes. I want to dedicate these 7 minutes to questions and comments. I will share a couple of references at the end of this call with everyone. So if you have participated in this meeting, please send me an email to carlo.cafiero@fao.org so that I can assemble a mailing list for this group. And again, if you want to raise a question, if you have a doubt, please raise your hand. I'm looking at the list of participants. Okay, I see Assad Bori, please. Probably need to unmute you.
Okay, thank you very much, Carlo. Thank you for your presentation. You told about the 2 principles for the measurement. You told about validity and reliability. Yes, reliability. So for the reliability, you told about the necessity sometimes to calibrate the measure by using a gold standard. So my question is, yes?
Yes, go ahead, sorry.
So my question is it always possible to have a gold standard for that kind of calibration for checking the accuracy of a measurement? Over.
Very, very good question. And the answer is no. There are cases in which a gold standard do not exist yet. And for example, if, and Marco will forgive me, today there is still no gold standard for resilience measurement. And if you want to allow my pretentiousness, since 2015, we started creating the possibility of a gold standard for household or individual food security measurement. And this is because, thanks to the activities of the project Voices of the Hungry, we have been creating a global measurement scale for reference against which measures obtained in different contexts, in different countries, with different set of questions even, can be calibrated against. So the answer is no. There is not always a gold standard, and the objective of advancement of measurement into this field should be trying to establish the gold standard. Having said that, however, we need to recognize also that calibration against the gold standard and concluding about the reliability of a measure is much easier in the physical science. And it's much more complicated in the social sciences. And in some cases, and we will go into very deep detail, the validity question and the reliability question can only be addressed in probabilistic terms. So there will be never certainty on the measure of reliability, precision, absence of bias. There will always be a probability of bias. And even the validity question needs to be carefully thought of, because if I'm not sure about the number I see when I produce it, how can I say that it has doubled following doubling of the resilience ability or doubling of the food security situation of a household? So even the validity question will need to be addressed in a very special way that uses statistical theory in a very important sense. But this will be the main topic of, let me just anticipate, we will be talking about the rush model. The rush model is the way in which the concept of measurement has been transferred into the social and human science. So the first reference that I will share is actually a book called Applying the Rush Model, and the subtitle of this book is called Fundamental Measurement in the Human Sciences. Because that, Assad, is exactly addressing your correct question. Is it always possible to determine validity and reliability? Some people have even concluded, and this was true in a period, I would say, around the 80s, 1980s, that measurement in the social and human science is not possible. Because you can never get to a gold standard, you can never get to a validity or an assessment of precision. So everything goes. From a philosophical point of view, I don't know if you're familiar with it, but there has been a postmodernist approach to inquiry in the social sciences that says, well, everyone is entitled to his own opinion and there is no basis to distinguish which opinion is correct and which opinion is wrong. In this concept, there was a paper that became quite famous by Simon Maxwell. I think it's 1992, if I'm not mistaken, that speaks of the postmodernist view of food security assessment. Well, thankfully, that vision has been correctly overcome. And yes, while there still is considerable margin of uncertainty sometimes because we don't have enough information to make assessment, but the principle and the possibility, at least in principle, to say this is a valid measure, although is not very precise, and this is not a valid measure, the possibility exists. So this is what we will be learning. And it's 3.1, and I apologize with everyone. I must close this meeting. Look forward to
Grazie mille, Carlo. Thank you so much.
You're welcome. I look forward to receiving your emails so that I can assemble the mailing list. And actually, Marco, if you can help also adding people that are not here.
Yeah, I will send a unique email to you, copying all of them, okay? And Carlos, it's much easier.
Perfect. Thank
Va
you.
bene. Thank you so much.
Carlo.
Thank you.
Bye.
Thank you.
Thank you.
Bye.
Thank you. Bye.
Ciao.
Ciao.
Thank you.